Hi everyone, we are glad to present our work drama, Joint Risk Localization and Captioning in Driving. This work was majorly done at Honda Research Institute. Situational awareness is an important requirement to achieve high-level automation in intelligent vehicles. An important aspect of situational awareness for intelligent mobility is to establish methods to communicate those risks through voice commands for cooperative and effective driving. For localizing risk there are some prior works that uses unsupervised and supervised techniques, also with two different representations of heat maps or bounding boxes. But none of the prior works address this risk localization problem jointly with risk agent captioning in driving. Similarly, there are prior works for image captioning that is related to risk or non-risk in both driving and non-driving scenarios. But none of the works address joint risk localization and captioning in driving. We divide the annotation into three levels: video level, object level, localization. Video level annotations are scene classification, ego intention, risk and suggestions to the ego car. Secondly, if there is risk, the annotators draws bounding box for the risk agent. Finally, the annotators answers multiple levels of questions with closed and also open choices of answers. Finally, these answers are combined to make a free-form captions. We compare our dataset with related datasets in risk localization and captioning dataset. For this joint task our dataset has very clear novelty and contribution to the community. An overview of risk localization and free-form captions can be visualized here for diverse scenarios from our drama driving dataset. Those top 50 common words distribution is plotted here. Most of them are pronouns, adverbs and adjectives and some common driving-related words. We use both image and flow to extract contextual and motion information in the scene. We first predict the caption using attention mechanism, and the hidden states from caption prediction module are again passed to another self-attention module, then predicts an important object that is being described in the caption. Since here we are predicting two different tasks, we also benchmark two different baselines shown in this slide. First, our approach, LCP, localization using captioning priors, predicts caption first and then localizes that object. Another alternative is CLP, captioning using localization priors. First we localize the object and then predict a caption describing the localized object. The third alternative is to treat these two prediction tasks independent of each other. For the two tasks, we use two losses: RMSE for bounding box regression and cross entropy for captioning, along with a regularizer for attention and captioning, adapted from show and tell paper. In our combined loss function, sigmas are trainable parameters. We call this dual task learning loss. For captioning evaluation, blue score is precision, rouge is recall, meteor is similar to F1 score with synonym matching. CIDR uses term frequency to weight the metric, SPICE calculated as an F score over tuples after creating a scene graph. For bounding box evaluation, we use mean intersection over union and accuracy with intersection over union greater than 0.5. Our approach outperforms compared to other baselines and ablations on most of the metrics as shown here. The efficacy of our DTL loss is shown here, when compared to fixed sum of two losses from two different tasks. Our network predicts to identify the important objects and also explain about that object correctly in most cases. Since the networks only outputs one important agent, during the multimodal output cases it fails as seen in figure G. Also in case of geometric relations as seen in figure H. From the top row, captioning failure cases, in some cases even with right object localization, the reasoning in captioning can be ambiguous or hard to predict. From the bottom row, localization failure cases, the network tends to attend to the objects closer to the ego vehicle as more important in some cases. The performance also drop was the caption length increases as seen here. Thank you for attending our presentation. For more information, please visit the paper and dataset links provided in this slide.